previous video, we learned that the degree measure of an arc is equal to the measure of the central angle that inscribes that arc. Well, in this video, we're going to look at what's called inscribed angles. So to understand how the relationship between an inscribed angle and the arc it intercepts work, let's look at this example. Given triangle ABC inscribed in circle O, where angle 1 is congruent to angle 2, let's find the degree measures of x, y, and z. Well, first, let's understand what it means for something to be inscribed. A figure inscribed in a circle is a figure in which each vertex lies on that circle. The word inscribed actually comes from Latin, in for inside, and scribe meaning written. So the word literally means written inside. So inscribed equals inside. So this figure, triangle ABC, is inscribed, meaning that each of its vertices is a point on the circle. So let's see what happens with the relationships we've learned in the last video. First, since angle 1 is congruent to angle 2, I can label that in my diagram that these two things are congruent. Second, since this is a circle and OB and OA are both radii, these two values will both be congruent, meaning that this triangle AOB is isosceles, so its base angles will be congruent. So now it falls to me to figure out what the measures actually are. Well, since triangle ABC is equilateral, that also means it's equiangular, and since each triangle contains 180 degrees, 180 divided by 3 would equal what each of those three equal angles would have to be. So that's going to be 60 degrees. That tells me that angle Y has to be 60 degrees. So that gets me Y. Now, angle 1 and 2 were congruent, and since this combined angle, ABC, would also have to be 60, that's going to give me 30 and 30. So angle 1's 30, which means that angle BAO would also have to be 30. And since that takes up 60 of the 180 degrees inside triangle AOB, that leaves me with 120 degrees for X. So I know that X is 120. Finally, since X is a central angle and it intercepts arc AB, and the degree measure of an arc is equal to the central angle that intercepts that arc, Z will have the same degree measure as X, meaning it's also 120 degrees. Well, now I want to make an observation. Notice that this angle, ACB, here, which is Y, intercepts arc AB as well. But rather than being a central angle, it's an angle which is formed on the circle. Its vertex is not at the center, it's on the circle. And its degree measure is exactly half the measure of arc AB. That relationship will turn out to always be true. And that gives us a relationship between what's called an inscribed angle and the arc that it intercepts. So an inscribed angle is an angle whose vertex is on the circle and whose sides are made up of chords. So for example, that would be this. I'll call this A, C, B. So angle ACB is inscribed. And as we just noticed, the measure of an inscribed angle is equal to half the measure of the arc it intercepts. So what that means in this particular case is that the measure of angle ACB is going to be 1/2 the measure of arc AB. And that's always going to be true. So in the context of some examples, if I know that an intercepted arc is 74 degrees, here this arc is 74, then the measure of the angle inscribed within that arc would have to be half of 74. So X is 1/2 of 74 degrees, or more simply, X is 37 degrees. So this gives me a way of finding the missing values. Vice versa, if I know the angle is 42, then 42 is 1/2 the intercepted arc, which in this case is x, so that x is 2 times 42, or 84 degrees. Okay. We'll also have instances where sometimes we'll have to put different parts together. So in this case, I have a central angle of 100 degrees, meaning that the measure of its intercepted arc is also 100 degrees, and the measure of the inscribed angle, x, would be half that 100, so that x is 50 degrees. Okay, so our two angle relationships that we've talked about thus far is that central angles are exactly equal to the measure of the arc, and inscribed angles are half the measure of their intercepted arc. Now we can also use other ideas related to circles in order to help us in solving for missing angles and missing arcs. One idea that is sometimes helpful for getting information is the fact that congruent chords will cut congruent arcs. Now this is an idea that we'll actually prove in class, but for now I'm going to show you how to use that in the context of this example. In number 5, since this chord is congruent to this chord, the arcs that they cut, namely this one and this one, will be congruent to each other using this theorem. So since this one is 135, this arc will also be 135 degrees. Well, since any circle contains 360 degrees, and I've already accounted for 2 times 135 of them, and 2 times 135 is 270, if I take that 270 out of that 360 degrees, I'll be left with 90 degrees, meaning that the measure of the remaining arc must be 90, so that these three arcs will add up to the 360 degrees of the whole circle. Well, if this arc is 90, and x is an inscribed angle, meaning its vertex is on the circle, then x would have to be 1/2 of that 90 degrees, which is 45 degrees. So we can use theorems like this to help us in more quickly solving circle questions. Sometimes we'll notice that theorems can actually follow from observations we make while solving. For example, in number 6, I have circle O, center of circle O, and I have this inscribed angle x. Well, angle x, if I follow its sides, is inscribed within the following arc. And since this arc is cut by a diameter, it makes it a semicircle. And a semicircle, or half a circle, is a 180-degree arc. Well, that would mean that x would be half of that 180, which is 90 degrees. And recall that 90 degrees is a right angle. That means that anytime I have an angle inscribed within a semicircle, it's going to have to be a right angle. Now that's another theorem that we can use to help us more quickly solve circle examples in the future. One more such observation we could make is that, say I have two angles inscribed within the same angle. So here I have an arc of 80 degrees. Angle y is inscribed within that 80, meaning that angle y would have to be 40 degrees. Angle x is inscribed within that exact same arc of 80 degrees, meaning that x would have to be half that, which is 40 as well. Well, this kind of gives us a clue that anytime I have two angles inscribed within the same arc, those two angles are going to have to be equal to each other, or congruent. So that gives us another theorem that we can use in future examples. Two inscribed angles of a circle which intercept the same arc will be congruent to each other.